Alright, Assalamualaikum warahmatullahi wabarakatuh. So for this lesson, we're going to go through some of the tutorial of chapter 4, which is aligned to the matriculation syllabus. So I have picked a few examples from the tutorial 4.3, which is question number 2, where this kind of question is always asked by the students. So by doing this kind of video, I hope that will clear some of your doubt. And I'll also go through another example, which is regarding the type of hybridization processes and how we're going to determine the geometry of this species. So we have two questions today. So let's start. Okay, so the first question of question number 2, what is meant by the hybridization of atomic orbital? So I think this one is quite direct to you, which is the definition. So basically definition, you don't have to really memorize it, but as long as you got the idea correctly, then you got the mark. So hybridization, basically mixing two or more atomic orbital in order to form a new set of degenerate hybrid orbital. So the key word here is mixing two or more atomic orbital in order to form a new set of degenerate, which is an equivalent energy, hybrid orbital. Okay, so the next one is we need to indicate the type of hybridization of carbon and nitrogen atoms in the molecule below. So they give you a hint where you have to draw the Lewis structure of the species in order to answer this question. So in order for you to draw the Lewis structure, you need to expand the structure that were given. So you need to ensure that all the atoms are octet in each linkage here. So let's do that. Okay, so it starts with nitrogen as a as the central atom, and then it is linking with carbon, linking with another nitrogen, linking with another carbon, and then linking with another carbon. So basically what it means by linkage is this linkage here. Okay, so there's 1, 2, 3, 4. So I need to have 1, 2, 3, 4 linkage as well. So as what you can see here, nitrogen is bonded with 2 hydrogen. So you link it with 2 hydrogen. Okay. So in order for the time being, the nitrogen only has 1, 2, 3 bonding pairs. So it only has 6 electrons. But you need to make sure it is octet. So you have to add up 1 lone pair here. Okay, so now it has 2, 4, 6, 8 electrons surrounding it at the central atom, and hence you can say it is octet. For the carbon, it has the branch with NH, so it will link with NH, and nitrogen will link with H here. Okay, so now the carbon only has 1, 2, 3 bonding pairs, which is 6 electrons. So we have to make a double bond in order for it to have 8 electrons surrounding it. And for the nitrogen, we put a double bond. Okay, you might be wondering, why don't we put a lone pair here? This is because for us to count we need to ensure that the carbon has the lowest formal charge, which is 0. So the formal charge of carbon carbon has 4 valence electron, and it will minus 1, 2, 3, 4 bonding pairs, and minus 0 lone pairs, and hence you got 0. But if you do it something like this, you will get 4 minus 1, 2, 3 bonding pairs minus 2. You will get negative 1, which is not plausible. For nitrogen, you have to do it as a lone pair, because 5 valence electron minus 1, 2, 3, 4, 5. So it becomes 0. So that's why you chosen a double bond here, not a lone pair. Okay. Now you continue with the linkage, where the nitrogen link with hydrogen, and then because 6, now you have to add lone pair. And then for the carbon, here carbon, I call it carbon number 2 maybe. Yes, carbon 2, carbon 1, and carbon 3. Okay, for carbon 2, it links with 2 hydrogen atom, so 1 and 2. So carbon has 2, 4, 6, 8, which is already octet. And so we can move on to the third carbon, where it links with only 1 nitrogen. So for the carbon, it has 1 and 2 bonding pairs, where it only has 4 electrons surrounding it. It is not octet yet, so it has to get another 4 electrons in order for it to be octet. So we will make a triple bond here, and therefore carbon will have 4 minus 4. The formal charge of carbon going to be 4 minus 1, 2, 3, 4, where it got 0. And for the nitrogen, it will also get a lone pair, so that the formal charge going to be 5 minus 1, 2, 3 minus lone pair electron 1, 2. So you will get 0. So once you got the correct structure, which is this one, you need to indicate the type of hybridization that happens at the carbon and nitrogen atom in the molecule below. So now, let's do that. For the nitrogen here, it has 4 electron pairs, which is 1, 2, 3 bonding pairs, and 1 lone pair. So you got 4. So it's gonna be, the type of hybridization gonna be sp3. Okay. For the carbon atom number 1, it is bonded with, it has 3 bonding pairs, which is 1, 2, and 3, because the double bond is considered as 1 bonding pairs. Okay, so it's going to be sp2. For the nitrogen up here, it has 1, 2, and 3. 2 bonding pairs, 1 lone pair. So it's going to be sp2 as well. sp2. Okay, and for the next nitrogen here, it bonded with 1, 2, 3 bonding pairs, 1 lone pair. So as you will expect it, it's going to be sp3. The upcoming one, which is C2, it is bonded with 4 atoms, where all the 4 electron pairs are bonding pairs. So it's going to be sp3 as well. And then for the C3 here, it is bonded with 2 atoms, with C and Cn, and it also has 2 electron pairs only, where both of them are bonding pairs. The multiple bond, the multiple bond or the triple bond here specifically is only considered as 1 bonding pair, 2 bonding pair. So it's going to be sp. Okay, and the end here going to be sp as well, because 1 bonding pair, 1 lone pair. Next, I will cover the next question, which is to describe the hybridization process and determine the geometry of the species of ICl2-. So in order for us to start to describe the hybridization process, we must always start with the Lewis structure first. Once you got the most plausible Lewis structure, and from the correct electron Lewis structure, you need to make that as a reference in order to make your hybrid orbital overlapping. So we start with counting the total number of valence electron first. Total number of valence electron. So I have 1 Cl, I have 1 iodine, so iodine have 7 valence electron, and I got 2 Cl. Hence I got 7 electron multiplied by 2, which is 14 electron. Now I have the negative charge here. Negative charge here means the molecule species receive an additional 1 electron. So it needs to be plus 1 electron. So the total number of electrons, valence electron that you have is 22 electrons. Okay. Now you need to draw the Lewis structure. So in order for you to draw the Lewis structure, you need to determine which one going to be the central atom. So in order for us to determine the central atom, we need to choose the most electropositive atom to be the central atom. So within iodine and chlorine, iodine is the more electropositive atom. So we make it as the central atom. Iodine bonded with 2 chlorine. So it will deduct by, it make 2 bonding, so we have 2 bonding pairs. So 1 bonding pairs represent 2 electron, 2 electron here, 2 electron here, so you already use up 4 electrons. So the balance that you have is 18 electron. The 18 electron is used to fill in the terminal atom first so that it is octet. So let's do that. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I've used up 12 electron, and the terminal atom are basically octet 2, 4, 6, 8. 2, 4, 6, 8. Okay, so I have balance of 6 electron. The 6 electron, I need to place it at the central atom. So I got 6, so I have 3 lone pairs. 1, 2, 3, 4, 5, 6. Okay, so I've used up all the 6 electrons. So I have no balance left. And then I need to determine the class of the molecule. So the class of my species is AB2, because I have got 2 bonding pairs, where B represents bonding pairs, and E, which is represent the lone pairs at the central atom, which is 1, 2, 3. AB2E3. Okay, AB2E3, if you were to look at the table, it gives you a linear shape. Okay, before I go any further, did I miss anything out? Okay, so some of you might have spotted it. I cannot leave the structure without putting the negative charge, because the species have the negative charge. So I have to bracket everything and mix a negative charge here. So you might be wondering how the negative charge are coming into the species. So in order for you to understand that, we need to calculate the formal charge. Okay, so the formal charge of iodine. So formal charge of iodine is iodine have 7 valence electron minus 2 bonding pairs, 1 and 2, and then minus lone pair electron. So we have to count 1 by 1. 1, 2, 3, 4, 5, 6. So we have 6. So 7 minus 2 minus 8, you will get negative 1. And then for chlorine, formal charge of chlorine. Chlorine has 7 valence electron minus 1 bonding pairs, minus 1, 2, 3, 4, 5, 6 lone pair electron. So we have to count 1 by 1. So we got 7 minus 1 minus 6 is 0. So this chlorine and this chlorine is the same, so they will carry the same formal charge. So it's going to be like 0 here, 0 here, and -1 here. So if you add up the sum of the formal charge, which is -0 plus -1 plus 0, so you get -1. So the charge of the sum of the formal charge of the species is -1. So that's why we have to bracket the -1, where the -1 is carried by the iodine atom. Now we need to describe the hybridization process. So as you know, at the central atom, it has 5 electron pair, which is 2 bonding pairs and 3 electron pairs. So you have 5 electron pairs, and hence it will become sp3d. Okay, 5 s 1 p3 4 and then d plus 1, right? So got 5 altogether. So 1 plus 3 plus 1, got 5 electron pairs. So now we need to draw the orbital diagram. So I'll bring this in the next page. Okay, now we start drawing the orbital diagram for the central atom. Okay, so for the central atom, we have iodine, has a valence electron of 7. Iodine atom has 7 valence electron, but as what you seen just now, the iodine carries a formal charge of -1. Okay, so basically the iodine receive another electron, so the iodine will have 8 electron altogether because it carries a negative charge. So now you have to draw the terminal atom. You have to draw the orbital diagram. So it have 8 electron altogether. So it is situated at the valence electron shell. So we have 5s, 5p, and 5d. Okay, so this one happens at the ground state. So we have 8 electrons, so going to be 1, 2, 1, 2, 3, 4, 5, 6. So total we have 8. But as what you have seen, in order for us to form 2 bonding pairs with chlorine, we need to have 2 unpaired electrons. So we have to excite one of the electron into the empty 5d orbital in the excited state. So let's do that. So iodine in the excited state. So we still draw like normal, 5s, 5p, and 5d. So one of the electron here is excited to the empty 5d orbital. So we're going to have 1, 2, 3, 4, 5, and 6. So total we still got 8, consistent to what we are drawing just now. So for the explanation, you can say that one of the paired electron in the 5p orbital is promoted or excited into 5d orbital, resulting of 2 unpaired electron, which is here and here, in order to form covalent bond with chlorine. It needs 2 electron pair because it needs to form one bond here and another bond here. That's why it needs 2 single electron. And then once you do that, you need to hybridize the orbital. So at the hybridized state, you basically mix 5s orbital, 3 5p orbital, and 1 5d orbital in order to form sp3d hybrid orbital. So let's do that. 1, 2, 3, 4, 5, and this one is the balance. This one is all sp3d because it mix because we combine or mix at the orbital from 5s, 3 5p, and 1 5d. So we got this one. So since we're combining 1, 2, 3, 4, 5, so we got 5 orbital. 1, 2, 3, 4, 5. Okay, and it is also consistent to what we have drawn, which is 5 electron pair, which is sp3d, s, 3p, and 1d. Okay, now we need to draw the electrons in this orbital. 1, 2, 3, 4, 5, 6, and 2 unpaired electron. Okay, so I can write the description as the mixing of 1 5s, 3 5p, and 1 5d generates 5 orbital of sp3d as shown here. Okay, now once we do that, we need to draw the orbital overlapping at the side. Okay, so as for guidance, you need to follow back the Lewis structure that you have drawn. Okay, the central atom is I. Central atom is I, and then it has a linear shape. So it's going to be like this: sp3d, sp3d, and then it has 3 lone pairs here, right? So just do that: sp3d, and then sp3d here, sp3d. So we got 1, 2, 3, 4, 5. So consistent. 1, 2, 3, 4, 5. So the 3 here, 1, 2, 3, that will not make any bond, but it has a lone pair at each of the orbital. So we can draw that one first. Sorry. So it should be 2 unpaired electron here, 2 lone pair here, and 1 lone pair here, and this orbital here and here will make sigma bonding with the Cl. Okay, so and Cl at the terminal atom, Cl will have 7 valence electron, so you're gonna have 3s2 and 3p5. Okay, but you can imagine that we have it 2 because we have 1 on each side. So as what you can see, only this 3p orbital, one of the 3 orbital of each atom, will take part in bonding. So 1 here and 1 here. So let's do that. So I label it in blue so that it's easy for you to identify the orbital. So it's come from the 3p, and you know that 3p has a dumbbell shape. Okay, so I label with 3p and then Cl. and the same time on the left hand side, Cl and 3p. And also one of the electron here will combine it with here, sp3d will combine with 3p in order to form sigma bonding, and we need to also show the electron in the center. Same goes to here, where I label it with another color, which is yellow color. The yellow color here with yellow color here. So it's going to make another sigma bonding. And we have the overlapping of the orbital are end-to-end overlap. So we have sigma bonding, and the electron spin are in opposite direction, because as what you learn in the Pauli quantum, the Pauli exclusion principle, there are no two electrons which have the same principal quantum number. Now, do you think you have done drawing the orbital? Okay, some of you might say yes, and some of you may say no, because as before, you also need to draw the bracket and the negative charges. So don't forget to do that. Okay, and if you were to compare that, this one and this one, you can see that the drawing is basically consistent. I at the center, iodine at the center. 5 electron pairs, where 3 of them are lone pairs. 1, 2, 3 are lone pairs. 1 sigma bonding on the right hand side, and 1 sigma bonding on the left hand side. And it overlaps with 3p orbital of fluorine because its valence electron is at 3p orbital, and same goes to here. So you can see that it is both consistent with an angle of 180 degree, and same goes to here, angle of 180 degree. Okay, I think that's all from me. Thank you for watching, and good luck in doing other exercises that will follow up. Thank you, and see you next time. Bye.